Hey, so since we're not having a meeting this week, I thought it would be kind of fun just to record a little differently so you guys can feel like we're hanging out. So anyway, hopefully you like it. Hopefully it keeps you a little more engaged than just like a blank screen with my voice. I'll try to do some funny, like, woo, I won't. Anyway, to the math. This is a continuation of yesterday's lesson. So if you haven't done yesterday's work on solving when something's in factored form, go back and do that. Okay, so we're working with polynomials. We're working with solving polynomials. Yesterday, the polynomials were already in factored form. So we set each piece equal to 0, each of the factors. It's called the zero product rule. If this isn't ringing a bell, you need to get on back to yesterday's lesson. Okay. Today, we're going to practice factoring. And remember, we talked yesterday, factoring just means rewriting a polynomial as multiplication. So we're going to do that today using a method called GCF. Okay, GCF stands for greatest common factor. All right, so this says to solve a polynomial equation using the zero product property, you may need to factor the polynomial. The whole 7B chapter is on factoring polynomials, okay? Which means writing it as the product of other polynomials. Look for the greatest common factor, the GCF of the terms of the polynomial. This is a monomial, so we're pulling one term out to the front. We're rewriting what's left, okay? And that thing that we're pulling out will divide evenly. We'll divide all the remaining factors evenly. You'll see when we do it. Okay. So first we're just going to practice the factoring part and then we'll practice the solving part. So right now we're trying to factor out the greatest common factor of 4x squared. I'm just going to write it a little bit bigger. 4x to the fourth plus 24x to the third. Okay. So we're going to do this kind of in two steps. The first thing we got to do is find the GCF. And we're going to focus on the coefficients first. So it's a number that you can multiply into each of those. Or you could think of it as what would divide evenly into those, okay? When one of the numbers is smaller than the other, I always check to see if that one goes into it. So would 4 go into 24? It would. So that's going to be our GCF, okay? Another one you might try is 2. Well, if you did 2 on this one, after you factored it out, you'd see that they were both still even and you'd have to factor out another 2, okay? So again, you're looking for the greatest common factor, the biggest number that multiplies into both of those. Now let's look at the x's. So you always look at these in terms of how many x's do each have. Like they each have at least how many x's, okay? So our first term, it's x times x times x times x. It has 4 x's. The second term is x times x times x. It has 3 x's. So they each have at least 3 x's. So that's going to also need to be in my GCF, okay? So my GCF here is 4x to the third. Now, I want to rewrite this as a multiplication problem. So I'm going to start by writing 4x to the third first. You write your GCF first. Then I'm going to write what I would have left over if I divide each of these by 4x to the third. What we're doing when we do GCF is the opposite of distributing. You're dividing a number out to the front instead of multiplying it through. I told you I'd do some animations. Okay, so go step by step. 4 divided by 4 would be 1. X to the fourth divided by x to the third. Remember, we subtract the exponents. You'd have x to the first or just x. Plus, okay, the x to the third, I'm going to cross those out. And you just need to do 24 divided by 4, which is 6. Now, I said yesterday in our lesson that sometimes in this chapter, you could just go in circles for hours. This is one of those times because if you want to check your work, you would just distribute. And if you distribute here, you would get 4x to the fourth 24 x to the third, that's right where we started. And then you might want to factor again, and then distribute again, and then factor again. You could go round and round all day long, okay? But once it's written as a multiplication problem and the largest factor is in the front, the greatest common factor, you're good. All right, if you need more time, pause. Let's go when you're ready. Okay, so we have 8y squared minus 24y. So 8y squared minus 24y. Okay, I want to first find the GCF, then I'm going to factor it. Once again, see what number goes into both coefficients. And this can be done a lot of times by just seeing if the smallest one goes into the bigger one. In this case, again, yes, 8 goes into 24. So 8's going to be our GCF. And then we have y squared and y to the first. So you always go with the smallest exponent that they all have in common. So my GCF here is 8y. So where I'm writing my answer, I'm going to have an 8y, and then I'm going to have a parentheses, and I'm going to go through and I'm going to divide everything by 8y. All right, so 8 divided by 8 would be 1. Y squared divided by y would be y. Minus 24 divided by 8 is 3, and y divided by y is gone. Once again, if you want to double check, just distribute. You end up right where you started. All right, when you're ready, continue on. Now we're going to put it all together. So there are two parts. Let's do the A part first. So this is 2x squared plus 8x equals 0. So the only part that's different from last problem is that it has an equal 0, and the directions now say solve. So we're first going to factor out the GCF. Then we're going to treat it like a problem from yesterday. So the GCF here. They're both even, so 2. And then the first one has x squared. Our second term just has an x. So I can factor a 2x out of each term. So I'm going to write on my next line 2x in the front. And then to figure out what I have left, I'm just going to go back and divide everything by 2x. So 2x squared divided by 2x would just leave me with an x plus a 4. Now, to find what x equals, we're going to use the zero product rule. Either the 2x equals 0 or the x plus 4 equals 0. All right, on that first one, divide by 2, divide by 2. X equals 0. Subtract 4, subtract 4. X equals negative 4. Now, I really like to take it back to the top when I check my work on these. If you plug it in here, that's great. But I'm going to plug it in all the way up here. Look, all the way up here. Wow. Okay, so when I plug a 0 in, 0 squared is 0, times 2 is 0, plus 8 times 0 is also 0. 0 plus 0 is 0. The 0 checks out. The negative 4, I'm going to write out because I can't do all that in my head. So I'll just write like check. Check, please. Plug a negative 4 in. So 2 times negative 4 squared plus 8 times negative 4. Negative 4 squared is positive 16 times 2 is 32. Plus 8 times negative 4 is negative 32. Does that equal 0? It sure does. Okay. So check your work. It takes a second and then you know you're right. I am going to move this guy over here a little bit. I'm getting a little crowding up my B space. Okay. Now, part B takes it a little further because I'm not equal to 0 right now. How can I make this guy equal to 0? What if I subtract 15n from both sides? Well, those would equal 0, right? And on my left-hand side, I would have 6n squared minus 15n. Here's a hint for you. I always keep the largest exponent's coefficient positive. So like your leading coefficient, right? That's what we learned in chapter 7a. I always keep the leading coefficient positive when I'm deciding which side to get everything to, okay? That's why I moved the 15n. Now I can do the GCF step. So previously, the smaller one always went into the bigger one, right? 6 does not go into 15. And 2 would be my other thought, but 2 does not go into 15. Ooh. Does 3 go into both of them? Yeah, it does. All right, and then I have n squared and n, so they each have an n, so I can throw an n into the GCF as well. So I'm going to divide by 3n. Divide by 3n. 3n is my GCF. Okay, 6 divided by 3 is 2. N squared divided by n is an n. Minus 15n divided by 3n is 5. The n's are gone. Equals 0. Not done yet. No, no, no. The zero product rule tells me that either 3n equals 0 or 2n minus 5 equals 0. Itch on my nose. I was wearing my mask all day. All right, divide both sides by 3. We get that n equals 0 as a solution. Here's a two-stepper, so we have to add 5, add 5. 2n equals 5. Divide by 2, so n equals 5 halves. That one kind of hurts the eyes over there. Let's see if I can fix it. Yeah, it's a 0. All right, we got to keep on moving. If you have questions, send me a hangout. We'll solve it together. Okay, now my numbering is a little messed up. I don't know if anyone saw that. The last one was 8, and now this one starts with an 8. So I'm going to real quick make this 9. Oh, man, now I just got to keep it going because then there is a 9. All right, then this one will be 10. This one would be 11. I probably should have mentioned that these started after yesterday's. So yesterday, I think we got through 5, and then today started at 6. So we haven't done 11 examples today. We're like, oh my gosh, I just won't stop talking. A lot of those were from yesterday, but this is our last slide for today, okay? So now we got to continue like putting it all together. So for number 9, I'm going to start by finding the GCF. So the GCF here. Well, there's no coefficient with the a squared, so I don't need to worry about that, but they all have an a, right? So I'm going to factor an a out front. When I do that, I'm left with an a plus 5. This one's going to be great because look, a equals 0, done. Don't even have to solve that first equation. Back here, a plus 5 equals 0, just minus minus. A equals negative 5. Boom. Okay, number 10. GCF. All right. 3 does go into 9, so that's a good one, okay? 3, and then they each have an S. So I'm going to factor out a 3S. So now I got to figure out what's left when I divide each term by 3S. So 3S squared divided by 3S, the 3's are gone and one of the S's is gone, right? So I would just have S minus 9 divided by 3 is 3, and S divided by S goes away. So I have 3S times S minus 3. Lots of 3's. So either 3S equals 0 or S minus 3 equals 0. Solve both of those. They're each one-steppers. You can kind of fly through here. S equals 0. And S equals 3. You're probably noticing that 0 is a very common theme today. That happens a lot with the GCF, especially if you're pulling out a variable, because a number times a variable, which is usually what the GCF is, when it equals 0, the variable is equal to 0. So 0 is very common GCF factoring. Okay. Now, last one. That says 11. It does not look very good, but you know what I mean. Okay, so we first need to get it equal to 0 because we're going to use the 0 product rule. There's no like 2x product rule. So I'm going to move everything to where my lead coefficient is positive. It just kind of keeps factoring a little easier than when it's not positive. So I'm going to subtract 2x from both sides. So I have 4x squared minus 2x. Now it equals 0. Now I can pull that GCF out front. All right, so between 4 and 2, 2 would be the GCF. X squared and x, we just have the x. So I'm going to pull a 2x out front. Oh, I'm so glad we're doing this example because I want to show you guys what happens. 4 divided by 2 is 2. X squared divided by x is x. Now, a lot of people will just be like, that's it, because I took this whole term and I put it right here. Don't do that, okay? Hopefully I didn't trick you. You need a placeholder back there, because if we go through the process and distribute, we need to think of, well, what would I need right here so that when I distribute, I still have that 2x term? And that's a 1, right? Or the other way to think about it is, what's any number divided by itself? If you're pulling the whole thing out front through division, it's going to leave you with a 1 because it's any number divided by itself. Either way, you need that placeholder of 1. Now, this one will be slightly more complicated because we still have a coefficient in there. So we have 2x equals 0. That one's going to be easy. Boom, boom. Let me change colors to make it a little interesting. Now, in the back, I'm going to need to add 1, gone. So 2x equals 1. And then divide both sides by 2. And I'm going to get 1/2 as a solution as well. Now, plug these bad boys back in. Check your work if you want. When you plug 0 in, you would get 0 equals 0. That's true. When you plug a half in, you would get 1/2 squared, which is a fourth. 4 times a fourth is 1. Equals 2 times a half. Also 1. Good. So they check out. Feeling confident. Okay, that is it for today. I totally forgot to time this lesson, so hopefully it's not too terribly long. But you do have homework. It's on big ideas. It is the second day of that 7-4 lesson. Tomorrow is that, if you're doing this on time, hopefully you're watching this on Tuesday. Tomorrow is that like student work day, teacher call home day. So again, if your grade isn't so hot, you're going to be hearing from me, or your parents are going to be hearing from me. But again, I'm going to say this over and over. Chapter 7B is a hard one. Don't fall behind. Keep up the pace, keep up with me, and ask me questions when you need to. Okay. I will talk to you all later. Thanks for joining me, and goodbye. Maybe. Okay, here we go. Bye.